Okay, welcome back. Now we work with the same problem just now, but now we put in the values. With the values, it'll be easier to appreciate the concept there. Now we got a shaft, and let me just highlight the values that's important. You got a tensile stress, tensile force pulling it, and a bending moment. So now let's convert this force into the values that we have. So we say tension force equal to force over area. So I got 2000 Newton divided by the area, pi 25 squared over 4. Area of a cylinder, area of a circle is a pi d squared over 4. Okay, let me just write down here first. Area is equal to pi d squared over 4. Or in other words, it's pi r squared. So it's pi d squared over 4. And then here I will got 4.04 megapascal. Because we work with Newton and millimeter. Now what about the bending stress? Bending stress, we have the equation here. Sigma b equal to 32m over pi d3. And substituting the value inside here, I say 32. The m is 500 times 10. Because the 10 is to convert the centimeter to millimeter. And pi 25 3. And that will give me 3.26 megapascal. Now I want to take a note here that why the 10 was introduced. So now this 10 here is to convert centimeter to millimeter. And you know that in the, we have been talking about this, you know that when we're going to do stress, we work with a unit that is Newton. Let me just put it in here, Newton. Distance will be in millimeter, and the stress will be megapascal. So this is the standard units that we use. So it doesn't need to convert it. Now let me put the stress on element A. Element A, earlier we have drawn it this way. So I'm going to draw the element A here first. Let's say the A is here. Element A, the tension, we have 4.07. Then the bending stress, which is making it compressive, is 3.26. So finally, the stress will be, finally there within one stress, either use tension or compression. So you see the tension is higher, so finally this will be tensile. And the value of that will be 4.07 subtract this 3.26, and I get 0.81 megapascal. That's element A. Now element B is very neat. Element B is very neat because basically element B only has tension. Element B will have 4.07, and that's about it. Now element C is another interesting one. Let me put the C here first. Element C first have a tension that is 4.07, and then from the bending you got another tension, so which is 3.26. In short, element C will have a significantly larger tension than before, and the value I have over here should be 7.33. And that brings me to the end of this video. Bye.